So how do you scare a math student? You make an answer a fraction. Math students are really afraid of fractions, and they're not that bad. I want to show you some tricks here so that you can wallop fractions. Let's do some math. So we have fraction multiplication. Don't freak out about this. It is going to be just supermaning across. You're going to multiply and multiply. But when you are multiplying, don't multiply right away. 2 times 27 is kind of big. What you can actually do is look across. What goes into 2 and 4? 2. And so I divide both by 2, and I look at the other cross. 27 and 6. What goes into 27 and 6? 3. So we divide by 3, that would be 9 and 2. Now that I've reduced like this, now I superman across. I multiply 1 times 9, I get 9, and 2 times 2 to get 4. Students also freak out when you have fractions on top of fractions, but they're really not that bad. All you have to do is keep switch flip. You keep the first fraction, 3/7, you switch it to multiplication, and then you flip. You do the reciprocal of the bottom fraction. So this is actually 3/2. I just flip 2/3 over. Then I can superman across, and I get 9/14. This is going to happen so many times in like trigonometry and pre-calculus. We do mx plus b, and we end up with things like this. Now, what is the slope there if we had this like plus 2? Well, we know the y-intercept is 2, but what in the world is in front of x? I call this the Polk rule. You can take x and actually move it to the side of a fraction as long as it's on top. So this would be 5/12 times x plus 2. So why wouldn't it work if I had it on the bottom here? Well, what I'm doing on the left side here is thinking of x as x/1. So if I move it outside, I can just call it x. But this is really 1/x. So if I happen to poke it out, I would have to write 5/12 times 1/x, which probably isn't that helpful. Also, you could also do this when you have complex fractions like 1/2 x/3. It's actually a lot easier to poke this out to the side. You would have 1/3 times 1/2 x. So maybe that's helpful. This brings me to the next thing. When you have a fraction divided by a plain number, you can actually just multiply the bottom by that number, or just scoot that number up here. So this would be 1/2 times 4, which is 1/8. So why does this work? You can think of this actually as 4/1. And remember the keep switch flip. You keep the fraction, you switch it to multiplication, and you flip the bottom. You do the reciprocal. This is really helpful when you have things like 1/x divided by x plus 1. It gets complicated, so you could just write it as x/x plus 1. Sometimes you have the same denominator on the top of the bigger fraction and on the bottom of the bigger fraction. So if you have this, you can actually just cancel these out and get 3/1. The next one is really useful when you're doing lines and mx plus b. This is called the butterfly. When you have a binomial or a trinomial or something with many terms on top of a fraction, then you can divide by circling each term divided by 2. So that looks like a butterfly. And then I think 4 divided by 2 is 2. 8 divided by 2 is 4. We're going to come out with 6. So why is this useful? Well, sometimes you have 2x plus 7 all divided by 3. That happens a lot with mx plus b. I'm going to circle my left, my right, and I can break this up. It would be 2x/3 plus 7/3. And then I use the poke out rule. I'm going to poke the x out. It's going to be 2/3 x plus 7/3. Another one that happens a lot is when you have a variable on the bottom in an equation. What you can do is you can do the switcheroo. I switch these two around. So it's actually the same as if x equals 60/5. That makes the equation a lot quicker to solve. X is going to be 12. This is really, really helpful when you have something in trig like 5/x. You can just do the switcheroo, and in your calculator you can do 5 over the sine of 30 all at once. The last one that I was taught in high school was when you're multiplying 3/4 x equals 12. A lot of teachers tell you to multiply by the reciprocal on both sides. And that works, but it didn't really make sense to me. My teacher told me to multiply by 4 on both sides because this is the same as 3 times x divided by 4. I'm undoing the divide by 4 first, times 4 on both sides. These cancel. I end up with 3x equals 48. And then it's just a simple divide by 3. Divide by 3, I get 16. Hope that's helpful, guys. If you like what I'm doing here, please subscribe.